Hello everyone, welcome to PW Gulf. So as you all know, we have started a PYQ series for JEE Mains 2024, and in the previous lecture we did wave optics PYQs. So today we'll be doing the previous year questions of the chapter dual nature of radiation and matter. In this chapter usually one question comes in the JEE Mains and it's a very easy short formula based question. No need to do large thinking process or derivational part, nothing like this. It's a very easy short question. So let's practice some of its PYQs. So the first question says, when light of frequency twice the threshold frequency is incident on the metal plate, the velocity of maximum velocity of emitted electrons is V1. Okay, so when we make a light incident on a metal plate, what happens? Electrons are emitted. So when nu is equal to 2 times the threshold frequency, then KE maximum, okay, that is half m V1 square will be equal to h nu minus h nu naught. So from here we will get half m V1 square is equal to 2h nu naught minus h nu naught. So from here we get half m V1 square is equal to h nu naught. Okay, now see next part. When the frequency of incident radiation is increased to 5 times, when nu is equal to 5 nu naught. Okay, what they are is saying, when the radiation 5 times the threshold value, maximum velocity is V2. Now Ke maximum is half m V2 square. Okay, half m V2 square, this will be equal to h into 5 nu naught minus h nu naught, the work function. We have to find the relation between V2 and V1, that is V2 is equal to x times V1. We have to find the x. Okay, so this is numerical based question. So we will get half m V2 square is equal to 4h nu naught. Okay, now divide the two equations. Sorry, divide the two equations. What we will get? We will get V2 square by V1 square is equal to 4. Dividing the two equations, 4h nu naught divided by h nu naught. Okay, so what we will get is V2 by V1 is equal to 2. So V2 will be 2 times V1, x will be equal to 2. Okay, so this will be the answer. This will be our answer. Very easy and direct question from this chapter. Okay, nothing sort of lots of calculations and lots of thinking. No, very easy questions. See next, a proton, neutron and electron and alpha particle. Okay, so this is alpha particle, have same kinetic energy. They are having the same energy if lambda p, lambda n, lambda e and lambda alpha are the de Broglie wavelengths of proton, electron and an alpha particle, okay, respectively, then choose the correct relation. We have to choose the correct relation. Now see, lambda is equal to h by p, or we can say that lambda is equal to under root of 2me. Okay, momentum is equal to under root of 2me. Now they are having the same energy, E is same, all are having the same kinetic energy, so lambda is inversely proportional to the mass. Okay, lambda is inversely proportional to the mass. It means electron is the lightest, so electron will have maximum lambda. Then because proton and neutron have the same mass, their lambda will be almost similar. Okay, they are having approximately same mass. Alpha particle is the heaviest among them, so alpha particle will have the least lambda. So correct option will be lambda E is greatest them all. This lambda alpha is the least, then lambda proton, neutron. So option number 2 will be the answer. See next question. This has come in 2022. All these are questions starting from 22, then 20, 21, then 20. Okay, electric field at a point associated with the light wave. Now we are given a light wave. See what is the equation for light wave? electric field of light wave, it is 200 sine into 6 into 10 raised to the power 15 t plus sine of 9 into 10 raised to the power 15 t volts per meter. Then we are given H value in electron volts. Second, if this light falls on a metal surface having work function of 2.5 eV, maximum kinetic energy of the photoelectrons will be. We have to find the maximum kinetic energy. Now for maximum K, we will take omega maximum. Okay, we will take maximum frequency out of the two, which is greatest, 9 into 10 raised to the power 15, that is the greatest. So omega, we will take larger value for maximum kinetic energy. Omega is this, omega is equal to 2 pi nu. So from here we can calculate nu as 9 into 10 raised to the power 15 divided by 2 pi. This is the frequency. Okay, and then we have to calculate KE maximum. Okay, we have to calculate KE maximum. KE maximum is h nu minus work function. So from here kinetic energy maximum is equal to h. What is h? We are given it in electron volts only. 4.14 into 10 raised to the power minus 15 into 9 into 10 raised to the power 15 divided by 2 pi minus W naught. W naught is 2.50. Okay, so when you solve this 4.14 into 9 divided by 2 pi, what you will get is 5.9. So KE maximum, this is 5.9 minus 2.5, so this is equal to 3.4 electron volt. Okay, so this will be the answer. Maximum kinetic energy is equal to 3.4 electron volt, so 3.42 eV. That is option number 4 will be our answer. Next question. Two identical photocathodes, they are identical, it means they have the same work function, receive the light of frequencies f1 and f2 respectively. Okay, identical photocathodes, it means same work function. Okay, if the velocities of the photoelectrons coming out are v1 and v2 respectively. Okay, so for first photocathode, it is receiving f1 frequency. So if we write half m v1 square is equal to h f1 minus w naught. Yes, this is for first cathode. Second cathode, it is receiving half m v2 square will be equal to hf2 minus w naught. Okay, incident frequency is f2 and photoelectron speed is v1 and v2. Okay, so this is what we will write. Now subtract these, what we will get, half m into v1 square minus v2 square is equal to hf1 minus hf2. Minus w naught plus w naught will get cancelled out. So from here we will get v1 square minus v2 square is equal to 2h by m into f1 minus f2. Okay, this will be the answer. v1 square minus v2 square will be equal to 2h by m f1 minus f2. Option number 4 will be the answer. Okay, so you are seeing these are very basic questions. Okay, the de Broglie wavelength associated with an electron and a proton were calculated by accelerating them through the same potential of 100 volt. If we accelerate them through the same potential, change in kinetic energy or kinetic energy gained will be equal to Q into V. Okay, so what we will have again, lambda is equal to h by under root of 2m qv. Now this will be the lambda. Potential is same. We have an electron and a proton. Okay, charge is same on both of them. Charge is same. So gain in kinetic energy will be same. Q is same, V is same. what should be the nearly ratio of their wavelengths? We have to find the ratio of their wavelength. So Q and V are same for both. So lambda is inversely proportional to root of m. So from here, lambda electron by lambda proton. This will be equal to under root of mass of proton by mass of electron. Now we know that how much heavier a proton is than electron. So you can directly substitute the values. If you don't remember it, you can use these values as well. So 1.00727 divided by 0.00055. Okay, so when you solve it, it will come out as approximately under root of 1860 by 1. Okay, so when you solve it, it will be coming out as lambda 43/1, approximate answer. So lambda E to lambda P is equal to 43/1. Okay, option number 4 will be the answer. Okay, option number 4 is the answer. Next question. An electron of mass m and magnitude of charge E initially at rest gets accelerated by a constant electric field. Okay, so electron is accelerated by a, initially it was at rest and it is accelerated by constant electric field E. The rate of change of de Broglie wavelength of this electron at time t, ignoring relativistic effect, is, we don't have to consider relativistic effect, we have to find rate of change of lambda, because when it is accelerating, its velocity will increase, momentum will change. So we have to find change or rate of change of lambda with time. So first case, force on electron will be equal to E into E. This much force will act on electron. So acceleration will be E by m. This will be the acceleration of electron. Because it is a constant electric field, so acceleration is a constant. Apply uniformly accelerated motion. V is equal to U plus AT. So U is 0 plus E by m into t. So velocity of the electron at any time t is this. Now calculate lambda. Lambda is equal to h by p is equal to h by mv. So lambda will be h by m into EET by m. M and m cancel. We get lambda as h by EET. Okay, this will be the lambda. Now we can easily calculate d lambda by dt. This will be h by E into E is a constant. Differentiation of 1 by t is minus 1 by t square. So from here we get d lambda by dt is minus h by EET square. This will be the answer. Okay, this is the answer. So option number 3 will be the answer, h by EET square. Okay, next question. If a semiconductor photodiode can detect a photon with a maximum wavelength of 400 nanometer, okay, so lambda maximum is given. It means E minimum for a semiconductor diode, minimum for a semiconductor, okay, for a, this is a semiconductor photodiode, okay, maximum wavelength, it means minimum energy. Minimum energy should be equal to band gap energy. Any wavelength having more, any wave or any photon having more energy, then the band gap will be obviously detected. So minimum wavelength, maximum wavelength means minimum energy, because energy is equal to hc by lambda. So when lambda is maximum, E will be minimum. Okay, so lambda maximum means minimum energy. Minimum energy should be equal to band gap. Minimum energy needed to detection is band gap. So from here we have to just calculate. We are given lambda maximum as 400 nanometers. So we have to find just the energy of this energy associated with this frequency wavelength, it will be hc by lambda. So energy will be h. Now see, we have to find answer in electron volt, so you can use the value of h in ev, or you can divide it. So it will be 6.63 into 10 raised to the power minus 34 into 3 into 10 raised to the power 8. This is c divided by lambda is 400 nanometers multiplied by what, 1.6 into 10 raised to the power minus 19 to get the result in electron volt. Okay, so we will multiply it by divide it by 1.6 into 10 raised to the power minus 19 to get the result in ev. So result what we get is 3.09 electron volt, which is approximately equal to 3.1 ev. Okay, so option number 3, 3.1 ev will be the answer. Okay, see next question. A particle A of mass ma is equal to m by 2 moving along the x-axis with velocity v0 collides elastically with another particle at rest having mass mb is equal to m by 3. So we have a particle m by 2 mass moving with velocity v0. This m by 3 is at rest. After collision, m by 2 will move with velocity v1 and m by 3 will move with velocity v2. Okay, if both particles move along the x-axis after collision, the change in lambda, okay, change delta lambda in de Broglie wavelength of particle A. Okay, we have to find the change in de Broglie wavelength of particle A in terms of its de Broglie wavelength lambda naught before collision is. We have to find the change in the form of lambda naught. So before collision, lambda naught is equal to h by mass. What will be lambda naught equal to? H by mv. So mass is m by 2 into velocity is v naught. So lambda naught is equal to 2h by mv naught. Now we have to find v1. What will be v1 is equal to? V1 will be equal to m1 minus m2 divided by m1 plus m2 into u1. This is the formula from elastic collision. Okay, and again we will have plus 2 m2 u2 divided by m1 plus m2. Now u2 is 0, so that's why that factor will get cancelled. So calculate v1. V1 will be m by 2 minus m by 3 divided by m by 2 plus m by 3 into v naught. Okay, into v naught. So from here we will get v1 is equal to, this will be m by 6 divided by 5 m by 6. M by 6 divided by 5 m by 6. So v1 is equal to v naught by 5. Okay, v1 is equal to v naught by 5. Now delta lambda is equal to lambda minus lambda naught. So delta lambda, now what is lambda? It will be h by mv. So m by 2 is the mass, v naught by 5 minus, this is lambda naught is equal to, or we can say it as lambda naught only. So substituted, this will become 2h by mv naught into 5 minus lambda naught. Can we write it like this? 2h by mv naught into 5. So this 2 into 5 will go above. So from here we can see this is equal to 2h by mv naught is lambda naught. So 5 lambda naught minus lambda naught, delta h comes out as 4 lambda naught. Okay, 4 lambda naught. This will be the answer. 4 lambda naught. Option number 2 will be the answer. Change in de Broglie wavelength will be 4 times the original de Broglie wavelength. Now see next question. Assuming nitrogen molecule is moving with RMS velocity at 400 Kelvin. Okay, we are assuming that it is moving with RMS velocity. So what is VRMS? VRMS is equal to under root of 3 kBT by m. Okay, the de Broglie wavelength is close to, we have to find the de Broglie wavelength. So de Broglie wavelength is h by mv. On substituting this, we will get h by m into under root of 3 kBT by m. So lambda comes out as h by under root of 3m into kBT. Okay, m and m will become, this is m by root m, this will become root m. So 3m into kBT. Now substitute all the values. Lambda is given as 6.63 into 10 raised to the power minus 34 divided by under root of 3 into, what is the mass? Mass given nitrogen molecule weight is given us. We are given the weight of one nitrogen molecule. Okay, so m is given to us. Boltzmann constant is also given to us. Everything is given into temperature is 400 Kelvin. Okay, so on substituting all these values, we will get lambda is equal to 0.24 angstrom. Okay, this will be the answer. When you will calculate it substituting all the values, what you will get lambda as 0.24 angstrom. Option number 1 will be your answer. Okay, so not very tough questions come, we can easily secure 4 marks. So always focus which chapters can give you short 4 marks. Okay, always prepare those chapters at the first hand. Do not delay those chapters. Target your chapters which are easy. Okay, which are very easy. You should not leave those questions which are easy ones. Okay, see next question. An electron doubly ionized helium. Doubly ionized helium is nothing but alpha particle. Okay, and a proton are having the same kinetic energy. If they are having same, E is same, so lambda is inversely proportional to root m, because lambda will be equal to h by under root of 2me. So lambda is inversely proportional to root m. Relation between their respective de Broglie wavelengths is, so electron will be having the largest wavelength, then proton because it is heavier than electron, then alpha particle, or doubly ionized helium because it is the most heavier. So which option is correct? Lambda electron is greater than proton than helium. Option number 3 will be the answer. Next question. The surface of a metal is illuminated alternately with photons of energy 4 electron volt and 2.5 electron volt. So first we incident a light having energy 4 electron volt, then photons are incident having energy 2.5 eV. Okay, the ratio of maximum speed of photoelectrons emitted in the two cases is 2. Okay, we are given a ratio of maximum speed. So V1 to V2 is given as 2. If we want to find V1 square by V2 square, this will be 4, or let us not write it over here, we will use it. Work function is what we have to find. Now if we write half m V1 square, this is equal to E1 minus W naught, and if we write half m V2 square, this will be equal to E2 minus W naught. Now divide the two equations. Divide the two equations, we will get V1 by V2 whole square. Okay, half m get cancelled, V1 square by V2 square. V1 by V2 whole square will be equal to E1 minus W naught divided by E2 minus W naught. Okay, this is the ratio. Now substituted, V1 by V2 is 2, so it will become square will become 4. E1 is 4 minus W naught divided by 2.5 minus W naught. Okay, now solve it. 4 into 2.5 minus W naught is equal to 4 minus W naught. We will get 10 minus 4. This is what we will get. So 10 minus 4, 6 is equal to 3 times the work function. So work function will come out as 2 electron volt. Okay, so this is a NAT, numerical answer type question. So you will write it as 2 electron volt. Okay, that will be the answer. Next question. An electron of mass m and a photon have the same energy E in the range of few eV. Both are having the same energy in the range few eV. We don't have to consider relativistic effects for electron. Okay, that means the ratio of the de Broglie wavelength associated with the electron and the wavelength of photon is. Okay, now for electron de Broglie wavelength will be h by under root of 2me, because electron is having the energy E. Now for photon, we are talking about electron first and then we are talking about photon. For photon, lambda E is equal to hc by lambda p, lambda of photon. So lambda of photon is equal to hc by E. They are having the same energy E. Now we have to find the ratio of electron to photon wavelength. So we will get h by under root of 2me, h by under root of 2me multiplied by hc by E. H and h gets cancelled. We will get root E by under root 2m into 1 by c. So lambda electron to wavelength of photon, we will get 1 by c into E by 2m raised to the power half. This is what we will get. So this will be the answer. Option number 4 will be the answer. 1 by c is E by 2m raised to the power half. This will be the answer. See next question. A particle is moving with kinetic energy E, okay, has a de Broglie wavelength lambda. If a particle is moving with kinetic energy E, so de Broglie wavelength will be under root h by under root 2me. If energy delta E is added to its energy, delta E is added to its energy, now the final energy will be E plus delta E. The wavelength becomes lambda by 2. Okay, wavelength becomes lambda by 2. So from here we will get lambda by 2 must be equal to h by under root of 2m into E plus delta E. Now the energy is E plus delta E, lambda is lambda by 2. Okay, so now divide the two equations, divide it or substitute the value of lambda. Both ways you can do. So 1 by 2 will come as it is, h by under root of 2me is equal to h by under root of 2m into E plus delta E. Okay, cancel what is getting cancelled. So root this gets cancelled. We will get squaring both sides. We will get 1 by 4e is equal to 1 by E plus delta E. So E plus delta E by E is equal to 4. So we will get 1 plus delta E by E is equal to 4. From here we will get delta E by E is 3. So we will get the answer as delta E is equal to 3. Now I am doing all the steps in detail. I am writing each one plus minus step also, so that those students who don't know these questions, they can get to know what the solution is. I'm not doing them so fast that so that the students who are not able to understand don't get it. That's why in exam you have to follow your pace, okay, because time is important, and you have to do in the shortest step as much as possible, okay. So delta E will be equal to 3E, option number 2 will be the answer, okay. So this is all about today's PYQ session. I hope it was helpful. Next time also will target such a chapter on which you can get 100% result, okay. One or two question comes and that you can do, surely we will target such a chapter. So take care everyone, keep studying, keep rocking. Till then, goodbye.